Okay, next we have the method in which the augmented matrix, the augmented matrix is reduced to row echelon form or reduced row echelon form using ERO is called the Gauss elimination method with back substitution. Later on, we will see how to perform the Gauss elimination method. So firstly, now we have to know what is your row echelon form and what is your reduced row echelon form. Okay, so look at here. We have several conditions here uh, to identify your row echelon form and reduced row echelon form. So now we have here the first condition is your zero row must be appear at the bottom of the matrix. So your zero row must be at the bottom of your matrix. Okay. Next, the first non-zero entry. Okay, first non-zero entry. So it must be start from the left. In any row not consisting entirely of zeros must be 1. So we call it as the pivot. Okay, pivot 1 or the leading 1. Okay. And number 3, if two successive non-zero rows, okay, then the first one in the lower row occurs further to the right than the first one in the higher row. Okay, later on we will see the example of the row echelon form. Okay, next number 4, if every column that has leading 1 has zeros in every position below the leading one, has zeros below the leading one. So we call it as a row echelon form or REF. And the last one, if every column that has leading one in every position below and above the leading one, we call it as the reduced row echelon form. Okay, so note that it is not necessary to reduce the coefficient matrix into RREF unless it is stated in your question. Okay, now let's see example. Determine which matrices are in REF or RREF or neither. Okay, so look at here. The first one, 1, 2, 3, 0, 1, 4 and 0, 0, 1. Okay, so before I forgot, REF, row echelon form, okay, it is actually referring to the form of ladder. Okay, so we have here echelon means ladder. Okay, a stair. Okay, so in here, let's see, we have the form of a stair. Okay, so the first entry, the first non-zero entry must be 1. Okay, this is what we call as the leading one. Okay, which means it is the leading one in the first column. Alright, so next, your leading one in the next column, okay, must be further to the right from your previous column. Okay, look at here, it is further to the right. And next, the leading one in your next column must be further to the right, okay, than your previous column. So this is what we call as the row echelon form. This is your REF, row echelon form. Okay, so this one is a row echelon form because below your leading one is 0. Okay, so to reduce into your reduced row echelon form, your equivalent matrix will be 1 0 0 0 1 0 0 0 1. Okay, which means you have in the form of ladder. Okay, and for RREF, reduced row echelon form, below your leading one and above your leading one must be 0 and 3. Okay, that is for the first example. Okay, next, second example. So second example is also the row echelon form. Okay, so look at here, we have a ladder. Okay, so make sure each row must consist one leading one. Okay, so each row, row 1, row 2 consists one leading one. Alright, so this is REF. It is not necessary to have leading one in each column. Alright, okay. If you want to reduce until RREF, then you will get the answer will be 1 0, then 5 2. Sorry, this one will be 0. So 0 1 2 0 0 0 0. If you want to reduce into the form of RREF, so this is your answer. Okay, meaning here we have a ladder. Okay, and below the leading one and above the leading one must be 0. Okay, the column without the leading one, then we just remain as it is. Okay, next C. So we have C here, we have the ladder. Okay, the first leading one in your row 1 and second leading one in your row 2. Okay, this one is in the form of RREF. Okay, since below the leading one and above the leading one is 0. Next, okay, next we have D is also your RREF. Okay, RREF, below leading one and above leading one are all zeros. Okay, next E. We have a form of ladder. Okay, so we have leading one in each row. Okay, then this one we call it as REF because you have 6 here, meaning it is not 0 in above your leading one. If you want to reduce until your RREF, it will be 1 0 0 3 0 0 1 3. So this is in the form of RREF. You have the ladder. Okay, so below the leading one and above the leading one is 0. Okay, next F. So look at here. In F, you have the ladder. Okay, but it is not a normal ladder. It is not a normal stair because your leading one is here. Meaning here, this one is not the row echelon form and it is also not the reduced row echelon form. This is neither. Okay, your next leading one must be in the third row. So row 3. Where is your leading one? Okay, so what you have to do in these examples, supposedly you have to write all the entire zeros at the bottom of your matrix. Okay, so this is the first condition in your REF. Okay, so let's see, if you reduce, it is actually will become as this one, 0 0 0 0. Okay, which means you will interchange row 3 with row 4, and this one will be 0 0 0 1. So this one 0 1 1 0 1 0 0 0. So let's check. We have in the form of ladder, and every row has their own leading 1 except the 0 rows. So this one we call it as RREF. Check. Okay, for G, so look at G. We have leading 1 in each rows. Okay, row 1 and row 2. But then below your leading 1 in row 2, it is not 0. So meaning here, this example, it is also neither REF nor RREF. Okay. Supposedly, you have 0 below your leading 1. Okay, it should be, when you reduce, it will be 0 0 0 1. So 1 1 0 1. So let's check. We have here, okay, this is your REF. Okay, one leading 1 in each row. Okay, and then below your leading 1 we have 0. So this is your REF. Then if you want to reduce into REF, then meaning you have to make it this as 0 if you want to reduce until REF. Okay.